waves are everywhere all the time, and they're constantly overlapping and canceling each other out. So for example, if I just like sing one operatic tune in this room, all the waveforms that my voice box or my larynx just created are now bouncing off of all these different walls in here, and they're coming back and hitting each other and overlapping, and it's this big storm of waves that, frankly, is really hard to keep track of, right? But we can kind of get a sense of what they do when they see each other, okay? Simply because, waves have these little humps, right? And those humps kind of behave as we would expect they would. So what do I mean by that? Well, let's say that I have a string, and I have one wave pulse like this, moving in this direction, okay? And then I have another wave pulse like this, moving in this direction, okay? What happens? What do they do when they meet, okay? Well, to be honest, they do what you'd expect. Whatever amplitude this is, right, and whatever amplitude this is, they just add. So at the moment they meet, they are twice as high as they were before, okay? And then once they pass each other, because they're still going, right, then you're just going to have the same thing you had before, where this guy is now over here, and this peak over here is now over here. All right? This is called constructive interference. It's constructive. They're helping each other out. Okay? So this is the first kind of interference that we're going to talk about. Interference is what happens when waves hit each other. Okay? So there's also something, understandably, called destructive interference, which is what happens when you have one peak, right, moving in one direction, and you have a trough moving in the opposite direction. And at some point, they are going to perfectly overlap, and because this peak has an upward rise or peak, right, and this trough over here goes down, they are going to perfectly cancel each other out, right? If this peak happens to be a little bit longer when they overlap, then it'll be a little bit lower, right? So basically the difference between those two amplitudes, right? But let's assume they're the same size. They're going to cancel each other out. And then when they pass, then you're going to have the lower peak on this side, or the trough, and you're going to have the peak over on this side, and that fellow's going to be going this way, and this trough's going to be going this way. Okay? This is destructive interference, right? This is when they don't help each other out. In fact, a peak and a trough are actually working to cancel each other out or subtract the wave. Okay? So constructive interference, waves work together and they add to a greater amplitude. In destructive interference, they actually kind of cancel each other out and work against each other. All right. Let us look at a misconception question that helps kind of explain these phenomena. All right. Before we get there, I just want to be clear. There's a million different combinations of what kind of interference could be happening, right? These peaks don't have to be the same height. These peaks don't have to be the same height. They're, in fact, most likely when waves approach each other, they won't be. So there could be very complex interference patterns, but this is the basics, all right? This is what to expect. Waves that both have peaks in the same direction will add to each other, and waves that have peaks in different directions will subtract from each other, just as you would kind of intuitively expect them to. All right. Now, this misconception says, what happens when two waves, such as waves on a lake, come from different directions and run into each other? Now notice, this question does not say anything about what those waves look like. It doesn't say whether they're peaks or troughs. It just says there's two random waves. And so we have to be clever and notice that in the question, right? So we can't jump to conclusions. We can't say, oh, they're obviously going to add, because what happens if one's a crest and one's a trough, okay? So they cancel each other out and disappear. Well, it's tempting to pick this one, right? But that would only happen if it were destructive interference, and we don't know enough about the waves to know whether these two waves will destructively interfere with each other. So A cannot be the correct answer. B says, if they are the same size, they cancel each other out and disappear. Is that true? Only, once again, if it's destructive interference, right? If the two waves in the water are approaching each other and they look like this, then they will constructively interfere. Again, we don't know, so B cannot be the correct answer. C says they get larger where they run into each other and they continue in a direction between the direction of the two original waves and larger than either original wave. Once again, this is only true, C is only true if the waves both have crests, right? But what if one is a crest and one is a trough, right? Then they will not get larger where they run into each other. In that case, they'll cancel each other out. Again, we don't know what the original waves were like, so we can't say. C, sorry buddy, you're outie. Okay, D, they may have various patterns where they overlap. Oh, that finally sounds a little bit more freeing, right? Because we know there's going to be some kind of a pattern, right? But each wave continues with its original pattern away from the region of overlap. Do we expect that? Yes. So once they overlap, right, there's going to be some pattern. We don't know what it'll be because we don't know what the original waves were. But we do know that when they go off past each other, whatever they originally were, right, their original pattern is going to continue. And that feels right to me. But let's take a look at E anyways. E, waves cannot run into each other. They always come from the same direction and are parallel. That is BS, my friends. Definitely can't be E. Waves can come in all different directions, all different varieties, and they definitely run into each other. So I like D for this one. And with that said, that's going to be the end of my discussion of interference for now. Interference is something that is going to come up at various times in the rest of this chapter, and honestly, all the way to the end of Physics 131, when we start talking about light more closely. But for now, we're going to move into the biophysics of sound.